All right, so I'm back for our second example today of looking at the same parabola given to us in both standard and in factored form, and then gleaning what we can about the characteristics of that particular graph. So this time around, let's consider f of x equals x squared plus 1x minus 6. And when I consider this particular graph, it is given to me in standard form here because it's of the form ax squared plus bx plus c. And as I look at it like this, one of the first things that I am going to notice is what's the y-intercept of this graph? Where is this graph going to touch the y-axis? And a parabola given to us in standard form is always going to cross the y-axis at the point 0c. In this particular case, c for this parabola is -6, and so the y-intercept of the graph is going to be 0, -6. So that's the first piece of our puzzle here, is our y-intercept. The second piece of our puzzle is going to be determining what the axis of symmetry for this parabola is. Now remember, an axis of symmetry for a parabola is a vertical line. The equation is going to be x equals some number, and it's this vertical line that is going to go directly through the vertex of the parabola, and each side of the parabola is going to be a mirror image of the other reflected over this axis of symmetry. So the formula that I use to find the axis of symmetry is x equals the opposite of b over 2 times a. The opposite of b is the opposite of 1, which is -1, over 2 times a. A in this case is 1, so 2 times 1 is 1. So our axis of symmetry is going to be -1/2, or if you prefer to write that as a decimal, -0.5. So that's our axis of symmetry. Now, if we wish then to find the vertex of our parabola, that's the point that the axis of symmetry is going to pass through. It's going to be that maximum or minimum point on our graph. And so to find that vertex, I am going to evaluate the function at -0.5. So I'm going to take -0.5 squared plus -0.5 minus 6. Now you can complete this calculation using your order of operations and simplify. You can use your calculator, you can use Desmos to assist you, but the result that you'll get is -6 1/4, or -6.25. So that's telling us that the vertex of this particular graph is going to be located where the x-coordinate is -0.5 and the y-coordinate is -6.25. So the pieces of information that we were able to glean about this parabola when it's given to us in standard form were the y-intercept, which is 0c, and then the vertex, which we found by taking that axis of symmetry and plugging it in and evaluating our function for that value of x. So now let's consider the same exact parabola, f of x equals x squared plus x minus 6, but let's rewrite it in factored form so that we can get a little bit, some additional information, pardon my reach there, about it as well. So we're starting with the same parabola, but now what we're going to do is we're going to try and factor it to get a better sense of some of its different characteristics. So I like factoring using the box method. So I'm looking for two numbers that are going to add up to equal b, which in this case is 1, but are going to multiply to equal 1 times -6, which is -6. So the two numbers that meet this criteria are 3 and -2. So I'm going to put a 3x here and a -2x there. And now I can work backwards using the box method here. And once I do that, I realize that this parabola, f of x equals x squared plus 1x minus 6 can also be rewritten in factored form as x plus 3 times x minus 2. Now, the reason why factored form is helpful to us is it gives us an opportunity to find the x-intercepts of the graph. And the x-intercepts are going to be located where the y-coordinate equals 0. So we're looking for where f of x or y equals 0. So if x plus 3 times x minus 2 equals 0, then one of two things needs to happen. Either x plus 3 equals 0 or x minus 2 equals 0. X plus 3 is going to equal 0 where x equals negative 3. And x minus 2 is going to equal 0 where x equals positive 2. And so the two x-intercepts for my graph are going to be located at, let me just slide this up for you here. My two x-intercepts are going to be located at the points negative 3, 0 and 2, 0, which is pretty nice. So I hope these examples are helping. So now let's take all these pieces of information and let's look at the graph of this function and see how the characteristics that we calculated algebraically are those same characteristics that we see when we look at the graph of the function. So remember, the first thing that we noticed about this particular graph when we did our calculation is we determined that the y-intercept of the graph should be negative 6. And if I look at my graph right here, there is the y-intercept, the place where my red parabola touches the y-axis is in fact at 0, negative 6. The next thing that we did is we found the axis of symmetry at x equals negative 1/2, which we can see that right there. I denoted it using a blue vertical line. That was really helpful, so we can see that line of symmetry or that axis of symmetry. There are the coordinates of our vertex here, negative 1/2, negative 6.25. And then last but not least, we're going to look at these x-intercepts. Notice my graph crosses the x-axis at 2, 0, which is exactly what our parabola in factored form told us it would. And also at negative 3, 0, which was the other location where the graph would cross the x-axis, and it was the calculation we computed when we looked at the parabola in factored form. I hope you guys are finding these videos helpful. This is what we're going to work on this week, looking at a parabola in standard form, changing it to factored form, and finding as many characteristics about it as we can. Keep asking questions. Keep up the good work. I miss seeing you.